All right, so we went through problem 2 yesterday. We are on to problem 8. Show that the value of the integral from 0 to 1 of the square root of x plus 8 dx lies between 2 root 2 and 3. Any idea what we might be using to do this? More or less, yeah.
Area under the curve?
No.
Solve the integral.
It's one of your properties.
Domination.
No.
I love that from.
Let's think of it today.
Max and min. Wait. Max min inequality? Wait,
Yes.
No. Oh yes. Okay.
All right, so we're looking at the fact that this has to be between these two numbers here. Okay, so to show this, we're going to do the integral from 0 to 1. Now, we're going to imagine that we're using x as 0 for right now. So this would be the square root of 8 dx should be less than or equal to what was given to us, the integral from 0 to 1 of the square root of x plus 8. It's less than or equal to the integral from 0 to 1. Now we're going to imagine that x is 1, and so that would mean the square root of 9 dx.
Okay, we're imagining it's 1.
Yes.
Is that gonna be for like all of them, or is it?
It's because that's the
Oh,
I
I see.
can't think of the word. Anyways, it's the parameters that's on it.
Okay, I see. So if it was like
2 to 3, yeah, we would be using 2 and 3 instead. Yeah. So this is then 2 root 2. Okay, or I think y'all know that's the square root of 8. Is less than or equal to this piece, which we don't have to do anything to it. Oh, I forgot the dx on it. Square root of x plus 8 dx less than or equal to 3. Now, what we have done is we've actually integrated these two pieces, okay? So if we took the antiderivative of the square root of 8, it would be square root of 8 times x. And then square root of 8 times 1 minus 0 is what's really happening to get us to this answer. Okay? We've actually done it without having to because of the way we've set it up. We just didn't really have to do it.
So would you always plug in on the bottom answer?
So it's for the less than one, it'll be the bottom, and then for the greater than one that's on the far side, you do the upper one. Trying to see if there's any more. There's not really any other ones like that one, but I can try to find one similar to it for you. When we do the next problems that are actually taking the antiderivative and like evaluating them, it'll make this part make more sense.
Okay.
But that's kind of what's happening there. Okay, let's see. 12 says to use NINT to find the average value of the function on the interval. At what points in the interval does the function assume its average value? So 12, y equals negative x squared over 2 on the interval 0 to 3. So we're going to be using this average value formula. Where was it? Up here. 1 over b minus a times the integral from a to b of f of x dx to do this. So, or like to set it up. So this is going to be 1 over 3 minus 0 times the integral from 0 to 3 of negative x squared over 2 dx And then we could take the negative out if we wanted to make this negative 1/3 integral from 0 to 3 of x squared over 2 dx. And at this point, we can use the calculator function if we want to type this in. Since it says to do that, we could also integrate it by hand, but we'll just use the calculator way. All right, so you're going to go to math, arrow down to FNINT. And then in the little boxes, we put in the different parameter things. So 0 to 3. X squared over 2. And then you have to do this little box out here. It just says the variable with which you're integrating. So it's that. Now, I didn't do the negative 1/3 before I started typing, so when I get the answer, I'll just have to do the times negative 1/3 at the end.
Okay.
So that integral is equal to 4.5. So this would be negative 1/3 times 4.5. And then times negative. Just negative 1.5. So then it says after that it also wants us to, at what point in the interval does the function assume its average value? So we're going to set this function equal to this number and solve for x and get that part of it. So that's going to be negative x squared over 2 is equal to negative 1.5. So that's going to be equal to 3. And then x is going to be equal to the square root of 3. And because that number is getting squared, we don't have to worry about the plus or minus part.
So what's the calculator function?
It's called FNINT. But your book is going to refer to it as NINT. So if it says to use NINT, you're looking for this function on the calculator, the FNINT.
Why does it do it like that?
I don't know. All the books typically say NINT, but the calculator, at least the TI-84s, say FNINT. I don't know. It's weird. I just roll with it. Okay. Now into the more fun stuff.
Yeah.
Actually solving integrals by hand. Interpret the integrand as a rate of change of a quantity and evaluate the integral using the antiderivative of the quantity. It's a really hard way to say evaluate the integral.
I don't know. Like, why do they use so many words?
The integral from 0 to pi over 2 of the cosine of x dx. So I want to find the antiderivative of cosine of x. So it would be sine of x. And when you do it, you can always go back and check. If you take the derivative of sine, you get cosine, so you can make sure that you've done it correctly. Okay? This is why we put all those up on the board yesterday. We evaluate this from 0 to pi over 2. So what this looks like is the sine of pi over 2 minus the sine of 0. So what is the sine of pi over 2? Sure, you have to know that unit circle.
There's one, right?
1.
Yeah.
What's the sine of 0? 0. So that's equal to 1. And you solved an integral. It's not that scary, right?
No, I'm not gonna say anything. 'Cause, like, I don't wanna speak.
No, wait, we kind of did that in the first section.
Just realized my watch is dead.
Oh,
It's
no.
all everything's dead.
We kind of did that.
It
in the
is,
first
everything
section,
is
didn't
dead.
we?
Do you charge your stuff like at night?
I think I had something else plugged into the USB charger for my watch, and I didn't put the USB back into the... Because it was on the charger. And I woke up this morning and didn't think anything of it. Popped it off the charger and threw it on my arm.
Oh, that's the worst. Oh.
R.I.P. I was like, why is my phone lighting up? It shouldn't be doing that because it doesn't do it with the watch, but I guess it does. Okay. 22. The integral from 0 to pi over 4 of the secant squared of x. So I need the antiderivative of secant squared. Tangent of x. Evaluated from 0 to pi over 4. So the tangent of pi over 4 minus the tangent of 0. So what is the tangent of pi over 4? What's the tangent of 0?
0.
0. It's undefined on the y-axis at pi over 2 and 3 pi over 2. So this is also equal to 1.
Yeah.
And my boxes are crooked for some reason, but we just won't worry about it.
Some character.
All right, something not a trig function. The integral from -1 to 2 of 3x squared dx. Oh, I forgot the dx on this one.
Functions are easier if you just memorize.
All right, so I need the antiderivative of 3x squared.
It has to be a oh.
Okay, so that would be
Oh. Wait.
x cubed.
Yeah.
Yeah.
Is that it?
That is
It is it, because when I move the 3 out front,
I'm supposed to plus C.
I get 3x squared. Okay, when we get to the indefinite integrals, then yes, you would need the plus c's, but we're
Okay.
not there yet.
Yeah.
So evaluated from -1 to 2. So we have 2 cubed minus -1 cubed, which is what?
is 7. 9.
9. I only got a straight one. Say, we've got the calculus down. It's just the algebra at this point.
I don't know how to algebra.
We kind of did this in the first section, didn't we?
This was
Is it like just gonna get harder in
Kinda.
this one?
Yeah, for a couple more problems.
Okay.
26. The integral, this one's going to get really hard, from 3 to 7 of 8 dx.
I'm gonna say the answer's 8. Wait, because we got, never mind. Don't.
What?
It's
What's the
8.
antiderivative of
Listen
8,
to
huh?
me.
8x.
Don't listen.
Evaluated from 3 to 7. So we have 8 times 7 minus 8 times 3, which is
8 times 7 is 56.
56 minus
3
1.
times 8 is 32.
32.
Why would it be 8?
Let's see.
No, I forgot to take
Oh, let's get crazy. 28.
Oh, let's get crazy. Don't get crazy.
The integral from 0 to 1/2
Oh, I hate that.
of 1 over the square root of 1 minus x squared dx.
Hold up.
Oh.
That just made me vomit.
That's
Terminal.
that's
That looks
sine.
so-
It's inverse sine.
That's what I meant.
Inverse sine of x evaluated from 0 to 1/2. This is going to require us to remember some trig here. So the inverse sine of 1/2.
So doesn't inverse sine only occur on like the right side?
That would be correct. That's a good thing you remember that. So yes, inverse sine only occurs on the right side from minus pi over 2 to pi over 2. So what is the inverse sine of 1/2 without your calculator?
Wait, no.
So where is sine equal to 1/2? On the right side.
3.
Sine.
5 or 6.
Pi over 6.
I was guessing. I didn't really know.
All right, what is the inverse sine of 0? So where is sine 0? Well, on the right side. At 0. So minus 0, so this is just pi over 6. So it's not enough to just know those however many 20 things or whatever are on the board over there. Okay, you also need to remember your unit circle.
I don't remember mine.
This might be a good time for us to do that.
Did we already do it once this year?
I think we did,
We
but
literally
apparently
had a quiz
we've
in the beginning of the
forgotten
year.
it.
We had a unit circle quiz in the beginning of the year.
All right, I'm going to do an odd one, which is out of the ordinary, but it's a necessity. The integral from 1 to e of 1 over x dx.
Okay, well, so we have ln of x.
Ln of x evaluated from 1 to e. So we have the ln of e minus the ln of 1. What's the ln of e?
1.
1. What's the ln of 1?
0.
0. So it's equal to 1.
I knew that.
Yeah, I was gonna say.
All right, I'm going to see if I can trick you on this one. 30. The integral from 1 to 4 of negative x to the negative 2 dx. Ethan's intently thinking about this one. I see the wheels turning. What do we have to do to the exponent when we're looking for an antiderivative?
X to the negative 1.
It's x to the negative third.
X to the
No.
negative 1.
It's okay, it's x to the negative 1 because we add 1 to the exponent. Okay, normally if it was x squared, we make it x cubed. But this is x to the negative 2, adding 1 is x to the negative 1. Okay,
Oh, right.
so x to the negative 1. Now what about this sign out front? Like, am I good? Like, I'm checking this, am I good? If I take the derivative, I'm good? Okay.
Oh.
That's what I'm doing that because I want you to see that. When you're going through and doing these on your own, I want you to see when you found your antiderivative that you check it back and make sure it works, especially with something like this one that we clearly weren't as confident about. Okay? So, yes, so we would be good here. Evaluated from 1 to 4. So we've got 4 to the negative 1 minus 1 to the negative 1, which would be what? You don't need a calculator for this. Put that thing away.
What do you mean I don't need a calculator?
What's 4 to the negative 1?
I don't know.
1 over 4. What's 1 to the negative 1?
I guess that makes sense. 1.
1. So let's do it as minus 4 over 4. So we have a common denominator. Negative 3 over 4.
I wouldn't have known that.
You would never be allowed to have a calculator on this problem on your exam.
I would fail that problem.
You don't know what 1 or 4 to the negative 1 is?
I did not.
Do you know what a negative exponent does?
No.
Put it where it ain't, make it positive.
Oh, I forgot about that. That's so long.
Throwing it back. Can't forget basic algebra. All right. Find the average value of the function on the interval using antiderivatives to complete the integral. Compute, not complete. Same thing. 32. Y equals 1 over x on the interval e to 2e. So we need the average value. So how would I go about setting this up using that formula?
One over 2e minus e
1 over 2e minus e.
times the integral of
Yep.
e to 2e.
Yep. Integral
Hold on,
e to 2e.
1 over x.
I don't know. Why did I write 1/2? Can we talk about that? 1 over
Where'd
x.
you- oh.
I was like 1/2.
I
1 over
I
x
thought it
dx.
was.
So that's our setup.
Mhm.
So what is, and we're doing this by hand. Okay, the last one we had like this, go down the calculator, but we can do this one by hand. What is 1 over 2e minus e? Not like the calculator number, but like how would we simplify that?
1 over e.
1 over e. So 1 over e. Then what is this, the antiderivative of 1 over x dx?
ln of x.
Times the ln of x, evaluated from e to 2e. Now, this is a constant out here. Okay, so what I can do is I can do 1 over e, and then in bracket, so I'll just multiply by everything at the end. Ln of 2e minus the ln of e. Now's the time to see if you remember rules of logs. What happens when I subtract 2 logs? I can divide. So this would be 1 over e times the ln of 2e over e. Now I have an e on top and bottom here. So I can cancel it, and I would be left with the ln of 2 over e. And because you didn't have a calculator for this problem, that would be a sufficient place to leave that. So let's review some rules of logs here. What's the log of a product equal to?
The sum of the base.
Sum of the logs. Okay. Log of a quotient is equal to the difference of logs. And what about when you have a power in a log? What can you do with it? Throw it out front. Okay. So those are some key things to remember. That's been a while since we did it. So like if, just for reference, this one here, if I wanted to, because this is a product, I could have expanded this to the ln of 2 plus the ln of e, and then it would have been minus the ln of e, and then those would have just canceled, and I would have just been left with the ln of 2.
Oh,
So that's another way I could have done it if I hadn't gone that way.
Oh, I see.
So, again, important to remember those rules as well. All right, one final problem. Same instructions as 32. 36, y equals the secant of x, tangent of x, from 0 to pi over 3. So how would I set this up? And in general, when you're doing, if you have one that's minus 0, you don't have to write that. But I'm just writing it for reference for you to see it if you look back.
Of 0 to pi over 3. Secant
So, now what?
So 1 over 3 times secant.
You telling me that's the antiderivative?
Yeah.
Okay.
And,
Just making sure.
yeah. And whatever, I don't know the word for it.
Evaluated from?
Evaluated from, there we go.
Evaluated from 0 to pi over 3. Now, would you agree that 1 over pi over 3 is equal to 3 over pi? Okay, so I'm going to rewrite this as 3 over pi just to avoid a fraction and a fraction. Times the secant of pi over 3 minus the secant of 0. What is the secant of pi over 3?
Secant's 1 over sine, right?
Cosine.
Oh.
Two root 2 squared root 3 over 3. I forgot the
What's the cosine of pi over 3?
2 over 3.
1 half.
Yeah.
So 1 over 1/2 would be.
2.
Oh, I'm thinking of sine.
So we'd have
I was good for this.
2 minus, what's the secant of 0? Or what's 1 over the cosine of 0? Where's 0?
Oh, 1.
1. So that ends up just being 1 times 3 over pi, so this is equal to 3 over pi. Not too bad.
I don't like these. I have to remember stuff.
Well, I mean, as long as you remember,
Yeah,
Yeah.
it's hard.
like, the math of it.
Alright. Problems. 1, which is going to be like number 2, so it's going to be long.
I do that.
3 is just like 1, so if you feel confident about 1, you don't really need to do 3, but anyways, it's there. 13. And then 19 through 35 odd. Actually, hold on. 19 through 33 odd.
I think it was the chair.
Oh, okay.
and, and 34, because 34 is different.
Different.
Not a bad different, a good
That was
different.
your wrist?
Yeah, that was Christian's wrist.
I thought he farted.
It was not my wrist. I just told you I farted. What do you mean?
Oh, you did fart?
I tried telling you that.
Oh,